Hey everyone, this is Mr. Mott. What I want to do is go through and show you how you can analyze a titration curve using your Labquest2. It's got a lot of really cool features to it. So I've got my data here. We got pH on the y-axis there and sodium hydroxide volume on the x-axis. What I want to do is figure out what's my point of inflection, what's my equivalent point, and we're going to have the Labquest do that for us. So in the top right, you're going to click where it says XY. It's going to give us our data table. So what I want to do there is I want to then make a new calculated column. So I'm clicking Table, New Calculated Column. I'm going to name it. So on the top right, I clicked in there. And just so we can kind of remember what this is, I'm going to call it the second derivative. If you had multiple calculated columns you were looking at, it might be useful to do that. Otherwise, you don't necessarily have to. The calculation we're going to have again is the second derivative. So in the equation type, I selected the second derivative. Hit OK. And then, so now it gives us sort of like what it looks like a heartbeat symbol to me. What we want to do is figure out that point where our line crosses the x-axis there, but there's no data point there. So what we're going to do is we're going to select this data point here at the top, or this area, and we're going to select that so that we can draw a straight line between that. So I'm going to go Analyze, Curve Fit of my second derivative. I'm going to choose a linear fit, so it's going to draw a line between those data points. So on the graph now we can see that line. So now what I can do, I can interpolate. If you don't draw the line there, you won't be able to interpolate between that piece of data. All right, so now what I can do is try to tap on that line, maybe drag that down, and then see where it fits. Let's see if I get it close as possible. It's pretty close. I'm not sure it's exactly close. So what I'm going to do is I'm going to change the axes and make them a little bit smaller. So I'm going to go into my graph options, change my y-axis here. I'm going to make the top like 5, and then the bottom I'll make smaller. Maybe I'll make it like -1 or something like that. Let's see how that looks. Okay, so now I can get a more finer point, hopefully. It's a little bit touchy of a screen. Ooh, where did it go? Gosh, it's really jumpy. I think maybe the closest I'm going to get is you know what? I think I'm going to make my, let's do this. Let's make my axes here a little bit tighter. Let's see if I can get it really on there. All right, so now let's see if I can move that down. All right, so that's probably as close as I'm going to get it. It's a little bit jumpy sometimes, depending on your situation. You can get it really close to there. It's pretty close. So I'm somewhere, but either that's 9.05 roughly. So I'm looking in the bottom right for my volume at NaOH. Maybe we'll call it the one above it was a little bit 19.04. So maybe we'll just call it 9.04 milliliters, and that's your equivalence point. That's how you find it. Okay. Now, let's say that we're at about 9. We can actually do something else there. We can look at the halfway point in to your equivalence point, and so that's what we're going to look at now. And we're going to use a similar idea. So first of all, I'm going to get rid of that calculated column because I think that's going to mess us up. So I'm going to delete that calculated column of the second derivative. Hit OK. And then I'm going to go back to my graph. And so what I want to do, since I know my equivalence point is right around 9, halfway to my equivalence point is going to be about 4.5. So if I click on some of these, so see, it won't let me interpolate right now. So what I want to do is try to get to there. So actually right there is right where I want to be in terms of knowing what the pH value. So it's telling me my pH is about 5.34 at that point. Now your pH at this point should be equal to your pKa. So if we were to look up the negative, or excuse me, if we were to look up or take 10 to the negative 5.34, we should equal the Ka for the phthalate ion. Now, if you didn't get so lucky where it was at there, what we would want to do is we would want to do a similar operation where we draw a line. So I'm going to first make my y-axis a bit smaller and change the top end to maybe around 6 or 7. So I'm going to go into graph options. Let's just make it 7 so we have a little bit bigger window to see. Go from there. So let's say that it didn't hit right on the button, and I want to interpolate. I'll select this area. I'm going to make a curve fit again of the pH, and we're going to make again a linear fit. And so it's drawing a line there. Now I'm going to make this area on the x-axis a bit smaller so we can interpolate a little easier. So I'm going to go under graph options, and let's make it from 3 to maybe 6, let's say. Hit OK. So now I can interpolate, and now I could really fine tune it. So let's say I thought it was really like 4.51. I could move this like so, and then I could use these arrows where it says left arrow, right arrow, and really get it 4.501 and kind of move it like that. I'm tapping on where it says 3 on the left. So let's say if that's where I really felt it was. So then it's telling me my pH is 5.341. So that's another way that you could use that that function of interpolating. But when you have a curve, it makes it a bit more difficult. If it was a straight line, that would be another thing. All right. So hopefully that's helped learn how to use your Labquest2 a little bit better. Thanks for watching.